The Sun provides Earth with approximately 84 terawatts of power, and we are only consuming about 12 to 15 terawatts worldwide. Some places even receive about 500 watts of power per square meter from the Sun. This is a clean, natural, renewable resource, and if we can harness this power, we need to put it to use. One such device that could really benefit from additional power are drones, as they have extremely limited battery lives, maybe 12-15 minutes at the most on average, yet they have endless applications. Such applications include researching or data collection, search and rescue, and even surveying dangerous areas that may be inaccessible to man. Hi, my name is Sebastian, and the title of my science fair project is Solar Drones, Making a VTOL with an Infinite Flight Time. So as I stated, drones have many uses, especially due to their ability to vertically take off and land. And solar power offers a very reliable power source, especially when there is direct sunlight. And when paired together, there is less downtime for the drone, which allows it to be used more efficiently. And lastly, most solar drones that are currently out there are only fixed-wing aircrafts. They are not VTOLs per se. There are a few, but not many. One such example is the picture right here, but it is not a fixed-wing aircraft either. So the problem I am addressing is whether it's possible to create a quadcopter with an infinite flight time. And my engineering goal to this is creating a quadcopter that would only be limited by its mechanical parts, such as the motors. When the motors spin extremely fast, they will create a lot of heat, which could in turn harm the motor as well as things around the motors, such as the motor mount. So many 3D parts were printed, such as motor mounts, motor ducts, and the base of the drone that holds the electronics and the carbon fiber arms together. These carbon fiber arms are very long so that they can support the solar panel in between them. A custom solar panel was even designed so that it could be lightweight and efficient. And then furthermore, the flight controller that I used was a Pixhawk 3DR Mini, and I used Q ground control to configure it. So one of the very important things, which is why I chose the Pixhawk, was that it allows me to record a myriad of data types pertaining to the operation of the drone, such as the power consumption and even things like thrust. So for testing the drone, it was anchored to the ground, or in my case, a table, which was the easiest place to anchor it to. And the drone was actually run at full throttle for the duration of the test, which lasted until a cloud blocked out the sun. And furthermore, for the solar panel, I used a buck converter, which allows me to set the voltage and the amperage to what I desire. And the voltage that I needed was about 11.5 volts, but I needed more amps than anything else, which I was able to output 8.45 amps. And this was all from a 100-watt solar panel. So the drone ran for about 7 minutes, which is when the cloud came over, and there was no battery used on this drone whatsoever. And the throttle was actually raised up in increments so as not to create a burst in current being needed, as motors need more power or current when starting up. It's similar to the idea that if you were going to, say, push a car off the side of the road or to the side of a road, it's a lot harder when you start than it is once you get the vehicle moving, which is essentially what happens here. So in conclusion, the solar panel successfully powered the drone, even though it is a much smaller panel than was designed. The panel that I had designed was about 142 or 192 watt solar panel, which would provide a significantly more amount of power, which would all be used in the amperage, because a drone needs a lot of amps to turn these propellers, especially to pick up a large solar panel. So this all proves the plausibility of a solar-powered drone. I was able to keep the motors powered throughout the entire duration of the test, and it also serves as a building block for future solar drones. So an obstacle I encountered, which was perhaps the main obstacle, was getting a custom solar panel made, as I had been communicating with a solar panel company to do so, but once I had submitted my design to them, they never answered me back, which led me to get a 100-watt pre-made panel to substitute this. Even though it is lacking the amount of power output, it was enough to do the testing. And it actually, my main concern was getting the motors to even start, whether the amperage would be enough. And furthermore, it was also planned to use motor ducts to increase the efficiency of the motors as well as the thrust, but due to their delicateness and size, the 3D printer was not able to produce enough in time. These motor ducts here are very thin and fragile. I actually broke a few pieces of this one just trying to get the supports off. So the next step in this project would be to actually get the custom solar panel made and then test it in real-world situations. A battery switching circuit would also be useful so the panel could charge one battery while the drone runs off the other, and when the battery is fully charged or the other battery is completely empty, it could switch over to the opposite battery and charge the other one. A fixed-wing version of the drone would also be very useful, as it would have the ability to glide if there's a sudden loss of power, which could happen, such as how my drone ended as a cloud came over. Thank you.